In this video, I'm going to show you how to convert grams of one substance into grams of a different substance, assuming that you have the chemical reaction in place. Now, here's the chemical reaction for these two questions, A and B, but it's not balanced yet, so we've got to start there. We've got to start by balancing it. So let's take a look at what we have. Here you have cyanide as a polyatomic group. There are two of them here, so we probably need to put two of them right there. There's two cyanides. This also created two hydrogens, but we have two hydrogens here. Here's one sulfate group, one copper, and one copper. So everything is actually balanced just by putting a 2 right there. So we'll fill in some 1s. Now that that reaction is balanced, we can look at this first question, A. It says with 400 grams of copper 2 sulfate, okay, what compound is copper 2 sulfate? Well, here's copper and here's sulfate. Sulfate takes a 2 negative charge, which means that copper has to be providing it with those 2 electrons, and that's why it's copper 2. So there's copper 2 sulfate. How many grams of hydrogen sulfate can you produce? So there's hydrogen sulfate. How many grams of this one can you make if you start with 400 grams of this one, copper 2 sulfate? Okay, let's show our work down here. You always start with what you are given, which is 400 grams of copper 2 sulfate. Put it over 1, and then build a conversion fraction. Okay, now whatever is on top right here, whatever this unit is, in this case it's grams of copper 2 sulfate, is going to go on the bottom of your next fraction. So always whatever's on the top of your preceding fraction goes on the bottom of your next fraction. So I'm going to go ahead and write that here. Copper 2 sulfate and grams. Okay, now I'm going to change colors here. Wherever you want to go from here is what goes on the top of this fraction. So you would really like to go to grams of hydrogen sulfate. That's what is being asked for. But you can't go directly from grams of copper sulfate into grams of hydrogen sulfate. You have to go through moles first. So we have to go from grams of copper sulfate into moles of copper 2 sulfate. So we're going from grams to moles here. Okay, now we have to come up with the numbers that work in this conversion fraction. So the number 1 always goes with moles unless it's a mole-to-mole ratio, which we're going to get to in our next fraction out here. But before we get there, how many grams, you ask yourself, of copper 2 sulfate is in 1 mole of copper 2 sulfate? How do you even figure that out? Well, copper 2 sulfate is made up of 1 copper, 1 sulfur, and 4 oxygens, right? So now we need to figure out how much each of these weighs, how many grams are in 1 mole of each of these substances. So let's go back to our periodic table. Where's copper? There's copper. We see that the average mass, or in our case the molar mass, is 63.546. So let's write that down. For copper, 63.546 grams per mole of copper. What about for sulfur? Sulfur is right here, 32.06. So sulfur is 32.06 grams per mole for sulfur. What about oxygen? Oxygen is here, 15.999, which for my purposes right now is so close to 16, I'm just going to round it up to 16. Alright, but there's 4 of them, right? See, O4, so you're going to multiply that by 4. Alright, now let's add all this up in the calculator. So we have 63.546 plus 32.06 plus 16, and 16 again, and a third 16, and a fourth 16 for all 4 of those oxygens. The total we get is this number right here. 159.6 is what I'm going to round that off to. So we're going to put down here for the total mass, 159.6. Alright. So we added up everything together in the compound. We got the total weight for 1 mole of it. Somebody's knocking up. Okay. Now we have converted grams of copper sulfate into moles of copper sulfate. What do we do next? Well, before we even get lost thinking about, oh, what do we do next? I'm stuck. You have this automatic thing that you should do without even thinking about it, where you take the top of this fraction and put it as the bottom of the next fraction. You don't even have to think about that. You just do it. It's like automatic process. So we have moles of copper sulfate here, moles of copper 2 sulfate here. Okay. Now we can think, okay, where can we go from this to help us get to our goal of grams of hydrogen sulfate? Well, we've got to convert into hydrogen sulfate, right? So we can use the molar ratio. We can go moles of one thing into moles of another. Moles of hydrogen sulfate. Okay? So we're going from moles of this one, transitioning to the next chemical by using moles of that one. Now, what numbers go here, now that we've built this? Well, that's just the numbers that go in our balanced chemical reaction. So what number goes with copper 2 sulfate? Well, that's the number 1. So we'll put a 1 here. What numbers go with hydrogen sulfate? Well, in this case, it's also the number 1. So that's pretty easy. It's a 1-to-1 ratio. And we don't even need to do any calculating. We can just go to our next fraction. I'm going to build that next fraction down here because I ran out of room up here. So, down here. Alright, now, what do? Automatically, we take this and put it as the bottom of our next fraction. Moles of hydrogen sulfate. And what are we going to put on top? What do we want them to go to? That is grams of hydrogen sulfate. There you go. So you can go from moles to grams, and that's exactly what we're going to do. Alright. 1 goes with the moles. What goes with the grams? Well, the sum total of all of this stuff. Now, we actually already did sulfur, and we did the 4 oxygens right there. All we need to do is 2 hydrogens on top of this. So instead of the copper, we're just going to do a couple hydrogens. Hydrogen is basically 1.008. 1.008. And that's going to be times 2. So back to our calculator we go. We go 1.008 times 2 equals that right there. And we're going to add our other substances in, 32.06 plus 16 plus 16 plus 16 plus 16 equals that, 98.076. So we're going to go 98.076. Okay, that's how many grams per mole are in hydrogen sulfate. Great. Now we have converted grams of copper sulfate into moles. And then we went from moles of that to moles of our desired unit. And then we went from moles of the desired unit into grams of the desired unit. Alright, that was quite a lengthy process, but we got there. So now we simplify all of this. This becomes 400 times 1 times 1 times 98.06. So let me erase this so that I have a little more room to write. I'm going to write out what we got. So we essentially have, I'm going to do this in green perhaps. On top of our fraction we have 400 times 1 times 1 times 98.076. That's what's on top. On the bottom you have 1 times 159.6 times 1 times 1 times 1 times 1, which is basically just 159.6, right? So we have this times this divided by this. So let's do that in the calculator. We have 400 times 98.076 divided by the number on the bottom, 159.6, equals 254. Does that number make sense? Well, let's write it out for a second. 245. Sorry if I said 54. 245.804. We'll just round that to the hundredth. 0.80. Okay, and just like always, we got to put our final unit. The final unit is the last thing that we converted to, because see, all these guys canceled each other out. So all we're left with is grams of hydrogen sulfate. So there is our answer. Okay, so let's see. We started with 400 grams of copper sulfate. We ended with grams of hydrogen sulfate. Now I asked if that makes sense. So if you just think about it, okay, the molar ratio was 1 to 1, right? So no difference there. Essentially what you have done is you have swapped in this compound a copper atom for 2 hydrogen atoms. Now which one should be heavier, copper or hydrogen? Hydrogen is going to be a lot lighter. See, if you look at copper, it weighs 63.5 roughly atomic mass units for one of its elements, and hydrogen just weighs 1. Now even though there's 2 of them, that makes a total of 2. Copper is still much heavier. So you would expect that your starting mass of copper to be a fair bit heavier than your resulting mass of hydrogen sulfate. And indeed we found that to be the case. 400 grams of copper and only 245 grams of hydrogen sulfate, because you're swapping it for a lighter couple of atoms. So that makes sense.